So thanks to be here for this talk, The Battle of the Circuit Breaker. I'm Nicolas Frankel. I've been a developer for like 70 years, working in the Spring Java ecosystem. 6 months ago, I decided it was much better to be paid to go to conferences, to talk to people, to have beer. That's much better. So if you have the chance, I encourage you to do that. I work for a company called EXOSCALE. EXOSCALE is a European cloud provider. So we provide cloud computing and cloud storage facilities. Who here is already using the cloud? And nearly everyone. Who is using Amazon? Few hands. Google? One hand. What else? What? Kubernetes, no, the cloud provider. The Azure, Microsoft, okay. So, who knows about the Cloud Act? Nobody, that's what I was afraid of. The Cloud Act is a US law, so you would say, hey, why should I care? Well, it's one of US law that applies everywhere. It's like GDPR, you know, it's a European law, but it applies everywhere. Cloud Act is a US law that applies everywhere. It says that if you contract with an American company, Microsoft, Google, Amazon, wherever the data is located, the government, the US government, has legally right to access it. No. Yes. No. Yes. Yes. And I can tell you the story about the Microsoft emails. So before there was a Patriot Act that said, hey, we can access your data, and Microsoft didn't want to give the emails, and there was a lawsuit. Well, sorry about the vocabulary. They went to court, and during that time, the Cloud Act was passed. They stopped the lawsuit, and Microsoft immediately gave the emails. That should be very serious. If you are using a cloud provider, you should make sure that it's not a US company behind it. It can be EXOSCALE, it can be anything else. There are other European cloud providers. Be very careful, because the data that I give you my trust as well as my data. If you are putting the data in somebody's hands that I don't know that can access it and do bad stuff with that, be very careful. Okay.
Just to comment this.
Yes.
If you think Azure is always Microsoft, you're wrong.
Okay, why? As soon as it's an American company, you are dead. If it's a European provider, that's perfectly fine. Okay.
Azure is not consequently driven or hosted
okay.
by Microsoft.
Thanks for the comment. Okay, that's a valid point. In this talk, we will talk, first I will have some introduction because I like to be very precise regarding the semantics. Then I will introduce the problem about microservices architecture, but even web services architecture. Then afterwards, I will tell you about one possible solution. In that case, it's called the circuit breaker. And then we will see different implementation. And in the end, I will demo a nice stuff to you. OK, so this is the microservice definition as per Martin's Fowler blog. It's not me. It's Martin's Fowler. So you can read free all the bullet points. Who is already doing microservices? Okay, half the room is doing microservices. In general, I tend to tell people you are not doing microservices. Because see those last 2 points. Last 2 points are not technical issues. Last 2 points are organizational issues, management issues. And basically, I guess that everybody here is a technical guy. So when we see that, we say, hey, we have services, we have smart endpoints, we have everything here, and then it stopped there. So most of the time, you could even got the business capability right. But I guess that those who raise their hand when I ask them if they were doing microservices, they still do it with project, not product. And the difference is that you have a start and an end. And because of that end, you sometimes have to do stupid stuff. You know what I mean, right? And The real issue with microservices is that most people think they are a technical solution to a technical problem. That's completely wrong. Microservices are an organizational solution to an organizational problem. Which problem do you think it is? Yeah. Responsibility, okay. Sorry, rapid change, okay.
Separation of concerns.
Separation of concerns. Between?
Multiple teams.
Multiple teams, yeah, I like where this is going. The only reason you should do microservices, the only reason, is when your development team is too big. When your development team is too big, you start having many feature branches, and then when you merge them, it's hell. Or if you want to do feature flags, then you have multiple feature flags, too many feature flags, and of course, since you have someone sometimes to cut corners, then, well, you have the same flag that is in different places, and it's a mess. And for that only reason, then you start thinking about doing microservices. And guess what? That means you change the organization. As technical guys, can you change the organization? Probably not. So, you know Conway's law. You know this guy. Yeah, well, this guy on the right, you know him. But you know the guy on the left? It's Conway. It's the guy. I was so happy to take the picture with him. And actually, his Twitter handle is Conway's Law. I mean, that's cool to have a law named after you. And so a lot of people say, hey, let's do microservices. You know, we will change the organization, and then we will have those microservices that will perfectly mirror the organization, because we will have the organization that is built around the business capability. Who told me they were doing microservices? Do you have this organization right now? One seems to say yes, which is pretty good, because in general it's 0. Perhaps 2? 2? Yes, perhaps 3? No, because it's very hard. This is a typical organization that we have been organized like that since a lot of time. So basically, you have like UX, and you have developers, and you have QA, and you have DB admin. And to do microservices, actually, you just take like a handle of them in every silo, and you make them work together. This is how Netflix is organized. This is true microservices organization. And this is probably how you are organized. And guess what? Here, at the top of each silo, who sits there? Managers. Your next best friend, right? The guy who is paid to accept your vacation requests, to do the reporting, and every year to be the proxy for your raise. And they are paid a lot to do that. I wonder why we are not manager ourselves. So that will never work. Because basically the only guy who can change the organization are the guys that will lose their job if they change the organization. So from an organizational point of view, you're probably not doing microservices, but the two gentlemen who said yes, they were organized like that. And then, of course, another reason to do microservices is because it will make the world better. Because now you have a shitty monolith. And then when you migrate, it will be a shiny new microservices architecture. Where chances are, if you don't know how to do a monolith, then probably you don't know how to do real good microservices. And even with Clippy's help, it won't change. So basically, if you have a bad monolith, if your architecture of the monolith is not so much good, then probably in the end your microservices architecture won't be so much good. So I will try as much as possible in the rest of this talk to talk about web services. Because yes, you can do web services. So web services, they are like semantically correct. It's just a technical issue. Microservices, again, it's an organizational structure. You cannot do microservices with a traditional legacy organization. So if you catch me saying microservice, just slap me on the wrist and tell me, no, it's web service. Anyway, you can, what I will tell you, it will apply to web service anyway. And so, of course, you know that, especially in software, but more in general, everything that can go wrong will go wrong. This is what architects do. I've been an architect. So we have a nice box here and a nice box there, and we say A call B. And on a whiteboard, it works perfectly well. Guess what? If it's an API call, chances are it will also work perfectly well. But the same drawing applies also to a network call. Again, it's a whiteboard. It's very abstract. Everything is fine. But you might know about those fallacies. This should be printed in every office that wants to do microservices. But even if you do web services, you should be very, very, very careful about that. And the worst one is the first one. If you do an API call, it's like a given that the call will succeed. Worst case, you might have an exception. But if you involve the network, chances are the call might get lost somewhere. Like if you do a rapid sequence of calls, in general, people think they will get the responses in the order they send the requests. I think it could be far from the truth. You have no clue. Again, because of the network. And this is a sample web service architecture. It can be microservices. It can also be web service. So I have a back-end web service. I have a front-end web service. And I have two clients. Right? Very simple. No rocket science. Now I have a request that goes from one client to the front. The front doesn't know or needs more data, so it will propagate the call to B. B gives the answer. Everything is fine. You are happy. That is the world we want to live in. Perfect. Now, for any reason, B is down. Or the network doesn't allow you to reach B, or whatever. Now when you start making requests, they get stuck. They get stuck on the first web service. And what happens afterwards when there are too many? F dies as well. And so that's a real problem with this architecture of web services, is basically one small mistake, one piece on availability at one point can propagate over the whole architecture. And that's what you don't want at all. You can fail, you will fail, but you want to fail fast. And you want to keep the failure localized in where it appears. So, enter the circuit breaker pattern. And the circuit breaker pattern for web services is the same concept as the circuit breaker pattern for electrical devices. You put something that will, I don't know how to explain it in electrical terms because I'm not an electrician, but it will melt if the current is too strong, and basically it will prevent your house from getting into fire, which is exactly what we want with our circuit breaker in the web service architecture. And this is quite simple, actually. And you see, I was really an architect. I can draw UML diagrams as well. So this is a state diagram. So at the start, everything is fine. The circuit breaker is closed. And then it works. You make calls. You make calls. You make calls. You make calls. You might have a failure. It still works for the next one. So it's fine. At some point, however, you might exceed a threshold. Like it starts failing repeatedly. What happens is that we will open the circuit breaker. And when the circuit breaker is open, afterwards, then every consecutive call will fail directly. You won't try to reach the service. You will just, the circuit breaker will say no. 500, whatever. But perhaps, and probably you want, that at some point, the service, the B service, might be up again. So after some time elapses, you will make tentatives to try to reach B service again. And so this is called the half-open state. In that case, you will try it, and as soon as it fails, then you close it, you open it again. But if it works, then you close it again, because it means that it's again in a good enough state. So nothing very hard. And you have a lot of configuration options available. First configuration option is how many failures do you accept before opening the circuit breaker. The second is how long do you wait in the half-closed before reaching the half-closed state. And what's the strategy afterwards? Let's say you go to the half-closed state and it still fails. Will you wait the same amount of time before retrying again? Or do you double that time or whatever? So there are a number of configuration options that are available. But the most important one is, what do you do when it fails? What do you do? What would you do if it fails? If your call fails, what would you do? Retry, okay. But then you know that basically it might be failing again. So what's your... You are in the open states. Fallback. Who said fallback? Fallback to what? Sorry?
We must configure something for fallback scenario.
Yeah, but what? Yes?
Tell the client that it fails.
Okay. Tell the client that it fails. That's for sure. Well, yes. Well, you are all right. Yeah.
Redirect to another instance.
Redirect to another instance. Those are all valid answers, but the only one that counts is it depends. There is no clear-cut answer for that. And I've worked in e-commerce a bit, and I try to take my example from there because in general they are rich enough. So what I will do is I will take like a sample of services that apply to an e-commerce scenario. So the first one is the recommendation web service. You know, you go on Amazon, and then when you buy something, then there is this little like banner saying, hey, people who bought this also bought this. It could be in an e-commerce architecture, it could be a good web service. Even if not a microservice, it could be a good web service. Another one is the pricing web service, because when you have a product, you want its price, and its price is not fixed. Price might depend on the time of the day. Price might depend on the business that decides to have a discount at that time. Price might depend on your status as a customer. Are you a regular customer? Are you like a premium customer? So prices are not fixed in e-commerce. Of course, you want to pay, so that payment service is also a good candidate for a web service. And finally, I assume that you want to have a overall monitoring of your architecture, and you want to understand what happens, so you probably have a logging web service. Okay with that? That's good. So logging is very easy. If you fail, you don't care. I mean, you are not expecting a response anyway. So in that case, you can just tell the client, nothing happened. Or even worse, when it's just fire and forget. So even you don't need an answer, a response. So you do nothing. And that's perfectly fine. Recommendation, however. Recommendation might be a bit harder to do because you want the client to get the recommendation. You want the client to get the recommendation. So you cannot just send the request and expect the response at a future time. You need it to be right now or very close to right now. So there are several ways to handle that, actually. As you said, one of them could be tell the client, hey, we failed. And then your front end display nothing. That's perfectly fine. Another way could say, hey, imagine we have like a static set of recommendations. Those are our best sellers. We want to sell them anytime, anyhow, anywhere. And they are hard-coded. So when it fails, then you send them. Another way could be, hey, we have like a more reliable web service that is not refreshed as often as the main one. And so the fallback is to call this other one. Or the client could keep a cache of all recommendations so far and serve them. There are many, many different ways to do that. Which one would you recommend? It depends. Thank you. So you understood how my mind works. Of course, it depends. It's not up to you to decide that. You should propose those solutions to the business with pros and cons, with costs and benefits. And then the business decides. But you should be like the one proposing options because you are the professional. Pricing. Pricing is even harder because, of course, you cannot just tell the customer, hey, we cannot sell you this item. We cannot get a pricing. Well, obviously you could, but not so great. Again, you should go to the business with proposals. One of the easiest proposals is caching. So yes, the price won't be right. So what? In general, the business will want to sell at any cost anyway, because it's better to sell at a slightly wrong price than at not sell at all. I mean, if you have been in e-commerce, you know what I mean. You want to sell as much as possible. And the payment. It's even harder. What if the payment service fails? What should you do? What could you propose to the business? Cancel the transaction. It's a possibility, yes. But again, no sales. No money. No salary for you. No payment, no money. What other alternative could you propose? Take the risk. So you accept. How would you accept like a failed payment?
Well, if it's below, let's say, 50 euros, I accept anyhow.
You accept anyhow, and so that means that you would like need to keep the credit card number.
Yeah, sure. Maybe I can check later, but
Yeah. But you know that if you start storing the credit card's details, that means that you need to comply with PCI and blah, blah, blah. I mean, okay, it's a valid proposition. And one of the cons in that case is to be PCI compliant. True. What could you do? Multiple payment providers, yeah. So you say, hey, we couldn't accept this one.
So we now have to go to the one that takes more.
Yeah, perfectly fine, yeah. But you could also like cache the order and say, hey, to the customer, hey, we will send you a mail later because right now we could. I mean, there are multiple options, and you have already named a few of them. Yeah. But basically, it all boils down to two basic strategies. Either you are in a black box mode, so basically you don't need fallback, it can just fail and whatever happens, happens. And then the Istio and service meshes are very, very well adapted for that. And the good thing is it can be like designed afterwards. However, as soon as you start to need to have a fallback, but again, that means that you must have thought about it before. Then you need to be white box because you need to be inside the code. You need to be inside the service itself. And then it cannot be designed as an afterthought. It cannot be set up just saying, hey, we forgot about that, let's do it, and it's done. That needs to be a very well-thought design before. And you might know about service meshes. Right now, service meshes are super hot because microservices are super hot because Kubernetes is super hot. And basically, a lot of features that we previously embedded in our application through libraries, now service meshes, they do the same. So they make your apps thinner. But just as the circuit breaker is not a one-to-one mapping, again, it depends. And who knows about Istio? Not so many people. OK, so basically, who knows about Kubernetes? Yeah, everybody knows about Kubernetes because it's so hype. Well, Istio is an install on Kubernetes. And basically, it plays the role of, like, let's say, the network communication. It handles all network communication between the pods. So once you handle all the network communication between the pods, it's very easy, like, I don't know, to send 50% of the traffic to this pod and 50% to the traffic to this pod. And then you have canary releases. Or it's very easy to duplicate the network traffic to another pod. And then, hey, you've got access to the production data. All things are possible now because of Istio. So it's open source, it runs on top on Kubernetes, and it uses the Envoy proxy. And it's very convenient because basically as soon as you deploy a pod into Kubernetes, then it attaches another pod. As soon as you deploy a container inside a pod in Kubernetes, it attaches a new container into the same pod. Hence, it's called a sidecar pattern, because every time you deploy a container in a pod, then it attaches one to it. This is pretty useful as a pattern. And from a bird's very, very high level view, then you've got your service here, and I told you that it proxies every network communication. So when you want to communicate with service B, you go through this Envoy proxy, and it goes through the other Envoy proxy of the pod of service B, and then it gets the routes to service B. So basically, between here and here, you can do everything you want. Like, fail fast, if you need. Or again, you can like duplicate content to something else and whatever. I mean, it's very powerful, but the principle behind it is super simple. And in Istio, this is the kind of stuff that you can do to have a circuit breaker. So notice that it's not called a circuit breaker. Before, it was called a circuit breaker, but they renamed it. So be very careful also, because as you can see, it's alpha. So it changes a lot. It's called destination rule. So there are like attributes that govern the configuration of this. Here is the number of consecutive errors you must run into before you open the circuit. I told you, number of consecutive errors is one configuration that is possible. Then you've got the interval, and basically the interval is a sliding window. So in one sliding window of 10 seconds, then you've got 3 failures, then it opens the circuit. How long it will keep the circuit open in that case. And something that is not possible in Hystrix is the percentage of eviction. Because basically, you are not calling one service. You are calling a cluster of nodes that give you this service. And because there is like this Kubernetes stuff, probably they all are governed by a replica set or whatever. And so the thought behind that is that it's better to have failing instances than none at all, because otherwise you are really dead. So perhaps in this pool, there are some that are still working. So let's still try them. This is only possible if you have a high-level overview of your architecture. So this is suitable to the black box approach. And of course, the problem of Istio is that you have no fallback. If it's open, it's open. You've got a 500 or 505, I don't remember, and it's done. On the opposite side of the spectrum, you have libraries, and I will use Hystrix here. I have a little disclaimer afterwards, but basically, Hystrix was developed by Netflix and is a way to handle like network failures. And the problem with Hystrix right now, it's in maintenance mode. And it has been superseded by something called Resilience4G. But don't worry, the same discourse that I'm giving you now applies to Resilience4G. I'm just using Hystrix because then I will show you a super nice demo with a nice dashboard that Resilience4G doesn't have yet. Hystrix works by, like this. You want to have a call, so you wrap this call into what they call a command. And then you execute the command. And because you were very smart, you designed a fallback into this command so that if the main call fails, then it will call the fallback. And if the circuit breaker is open, then the fallback gets called directly. Problem of Hystrix is there are a lot of configuration options. Really a lot. And also, as I said, you have no big picture because you are inside your service. You don't know how many nodes of your own service they are running. You don't know how many nodes of the service you are calling are running. You are just like inside. But that's good if you want to provide fallback logic. Also, there is something called Spring Cloud Netflix. Perhaps you know about that. I mean, who here are Spring users? Yeah, nearly everyone. Spring Boot users? Same people. Spring Cloud users? A few less, yeah. Well, they are built on top of each other, so it's very easy. Like Spring Boot is built on top of Spring Cloud is built on top of Spring Boot, and Spring Cloud did a nice job integrating like a lot of libraries that were provided open source by Netflix into a Spring Cloud, and they call it, there is a starter kit called Spring Cloud Netflix. So you have Eureka, Feign, whatever. And now I think I've talked a lot, and it's time for a little demo. Yes, sure. Questions are always welcome.
Just for my understanding, sir, suppose my microservice is running on 3 ports.
So you have microservices.
Yeah.
Real microservices or just web services? I spent 10 minutes!
Maybe web services. Yeah.
Okay.
So they're running on 3 ports.
They are, sorry?
They're running, I have 3 ports.
Okay.
Which are hosting that. And if I configure my circuit breaker on the network level, will it check that all the pods are not responding for that particular functionality before it opens?
Okay, so the question is if you have a service that is running on different services running on different ports, I'm right? Is that what you said?
Or maybe the same service running on different ports.
Why would you have the same service running on different?
For load balancing.
Pods, sorry. Sorry. Okay, so if you have like your service running on different pods,
and one of the ports is down.
one of the pod is down. No, it will. That's the good point is because again, I will just need to rewind it. Here. So basically here, you are calling a container. So it's not about the pod being down, it's about the container being down. And if you have like different boxes here, then you will, the Istio proxy will be like calling one of the other. So it will only this pod that will be marked as down. And then if you call another one, everything will be fine until you reach if other are failing, as I mentioned, until you reach this limit. Did I answer your questions? Great. Now for the recording, I'm not sure I repeated the question correctly, but okay, demo time. Finally, some codes. So here I've modeled a very stupid e-commerce shop with only two services. The one, pricing services. It's Kotlin codes, but I guess you can read it. Who cannot read that? It's fine, I can describe it. Perfect, everybody can read it. So I have a pricing handler, so it's a Spring Boot application. It's a reactive Spring Boot application that I handled with Kotlin. And I have these quotes that will be called in my handler, in my root. And what quote does is it computes the price from the ID of the product. And for computing the price, I have a very, very important formula here. I just get the hash codes, I restrict it to a byte, and then I put the double, and then I jitter it a bit, because I don't want every price to be the same, but I still want to be in a constrained range. And then I get the lowest, the integer that corresponds to that. So very stupid. And more importantly, you can see that I apply a network simulation. A network simulation is I have a counter, and after 5 calls, after a timeout grace count, so here it's 5, I don't remember how, I think I configure it to 10, it will only work 1 out of 5 times. That's how I'm trying to do the failure stuff. And this will be called by a client, so the shop client, which basically just call the quotes. And here I'm using Spring Cloud Netflix with Hystrix. This is the main method that basically will do the call. So here you see the template get for object, which is the basic way to do call with REST templates. I pass the quote URL, I pass that I want to double, and more importantly, I pass the ID of the product. In all cases, I will cache the result. Okay? And this is guarded by Hystrix. So if it doesn't work, I will call the method get quote from cache, and get quote from cache is just return it from the cache. Both methods, they wrap the results in an object, and this object just adds the origin, whether the origin is from the cache or from the service directly. Works for you? So let's see how it works. I will run the pricing application first. And because it's reactive, it should be very, very fast once it compiles. That's it. It was fast. And now I can run the shop application. I have 4 minutes left. Okay, and I will do the circuit breaker here to show you how it works. So because the grace count is not passed, it's very easy because I'm on localhost, no network latency, no network problems, everything is fine. It tells me the price of object foo. Foo bar is like whatever, and it comes from the service. Okay? So now what I will do is I will run a script to do that automatically because I'm super, super lazy and I don't want to click all the time. And what the script does is, is just repeatedly call it. I just repeatedly call the same URL. So at some point, normally I should fail because again, I will override the grace counts. And I told you I have this like nice dashboard of Hystrix. And in this nice dashboard, you can see, it's too small. I will just bring it up a bit like that. Okay, here. You can see here that about 1 in 5 is successful now. So everything went fine, and then now it starts failing every now and then. There is none that are short-circuited now. None of them, because I don't have enough load. So it's still able to handle the load so far, given my configuration. And the configuration is basically, I have 2 queues of 5 items each. So as long as those are not overloaded, it can still continue doing its calls. So I'm failing, but I'm failing in a good way right now. It's fine. This is usually the test you would do when you are developing, saying, hey, everything is fine, I'm failing, but it's fine. So let's add some more loads. So now I have 2 clients. And you will see that I'm failing a lot more. And you can even see that some of them are rejected because now the queues, they are full. So the requests, they are not sent at all. But still, I don't have enough load given my configuration. The circuit is still closed. So let's add one more client. And now you should see that, the circuit breaker opens now. And you see that the load decreases a lot. You can see that the short-circuited responses are here. And now I fail fast. I'm giving stuff from the cache directly. So this is how, and of course, after some time, because I configure it, it tries again. It gets hit on the 20% that works, and then it closes the circuit again. And because, that's very stupid configuration. It's just to show you how it works. Now it's closed again, then it will open again because there are too many failures, blah, blah, blah. This will never happen in real production condition, of course, but I think it's a nice way to demonstrate how it works. Okay, thanks for your attention. It's already time. You can read my blog for Java, Spring, Kotlin, container, CI/CD stuff. You can follow me on Twitter. You can check the sources of those 2 projects. that I've showed you, because then you can play with them, and perhaps you might want to like play with the Hystrix configuration to check whatever works and whatever doesn't. And here you can find the article that is at the root of this talk. I don't know if we have like 15. Wow. Okay, that's super fine. I thought I didn't have much left. Great. So I have 15 minutes for questions. Yes?
Is it possible to chain fallbacks in Hystrix?
Yes. So the question is it possible to chain fallbacks in Hystrix? Yes, it's possible. I mean, a fallback is just a method to call. So if you call a method that like embeds a web service call, no issue. And then you can like have like multiple fallback or fallback. I, however, wouldn't recommend doing it too much because, again, it's very, very complex, and afterwards it's hard to reason about.
Does Istio offer a user interface like you were showing about?
So the question is, does Istio offers a user interface? To my knowledge, it offers a user interface, but not like this one, not like the Hystrix dashboard. Likewise, Resilience4J doesn't offer a dashboard yet. But I believe if someone is motivated enough, then he could do it. Yes?
You said Hystrix is in maintenance mode?
Yes.
It's no longer adding something, some bug fixes maybe. And you said Silence4J is a basically replacement. What you would recommend to use if we would now, if someone now starts something?
Okay, so the question is, since Hystrix is in maintenance mode and Resilience4J has been elected as its successor, what would I recommend? If you asked me that question a few months ago, I would have said go for Hystrix, even though it's in maintenance mode. But I know now that, for example, Spring Cloud embeds also Resilience4J, and they created a circuit breaker abstraction. So basically, you can put which one you want. So perhaps the next version of this talk will use this abstraction, and then you can use Hystrix, and then you can, I mean, it's like Spring. So you use the abstraction, and you remove you change the implementation whenever you want. If you don't use Spring Cloud, you can still, I believe, use Resilience4J. I'm not sure the dashboard in itself is interesting enough, but for demo purposes. For demo, it's really great. I'm not sure in production you would like have something like that to monitor. Yes?
Can we combine Istio with
Hystrix? So the question is, can we combine Istio with Hystrix? Well, if you followed my points, not only could you, but you should. However, for different services, because some of the services, I mean, it's not interesting to have Hystrix. Like if you have like a recommendation engine service and you want to display nothing if you fail, then why would you need to put Hystrix to just return an empty set or whatever? It would just be like, I mean, again, I'm lazy. It would be for no good. Then it's much easier to have Istio. As soon as you have Istio, but of course that means you also have Kubernetes, that means a lot of stuff. So I'm assuming you have both. On the other hand, if you want to, like I displayed, to have a cache, for example, then Istio cannot help you with that. So in that case, you can forget about Istio.
But we cannot combine them in the same service.
You can, but why would you?
Yeah, so then I will have fallback, I will use Hystrix just for fallbacks and circuit breaking.
Yeah, but how does it work? I mean, if you fail fast, it's 5 ho-ho, and then... No, I mean, it's not because you can that you should. I mean, again, yes, we can do a lot of things, but what would be the point?
Yeah, I use circuit breaker.
No, that's... well, the basic of this talk was, it was mainly for architects that sees, like, circuit breaker, Istio as circuit breaker, Hystrix as circuit breaker. Oh! We can remove Hystrix and put Istio, and everything will be fine. It's not that, I mean, again, on the dashboard, on the whiteboard, it works, but in detail, it doesn't work like that. So they are not interchangeable, and why would you want to use both at the same place? Yes?
You showed that if you call another service and you don't get a response, then the circuit breaker
service attacks. So there are other sources, not strictly only the calling another service case.
For the question, I will rephrase also for me, but also for the recording, is I'm using the circuit breaker when the calling service fail. Caller service, well, the backend. But do I have any experience in using the circuit breaker for other reasons, like denial of service attacks and something like that? No, and I wouldn't use the circuit breaker in that case, because if you call, you are definitely one doing the denial of service. If you are calling,
No,
the question. If I'm called. Yeah, in that case, I would probably use an API gateway, which is basically one of the main use case for that. Proxy and API gateway and whatever. Yes?
But with resilience for J, you can easily configure a rate limit.
Yes. I'm not an expert of resilience for J, but go on.
You can define, like if you try to avoid denial of services with the service you are calling, you can define a rate limit. And say,
Okay.
if this is called, I don't know, more than 1,000 times a second, I limit it and give back immediately.
Okay, so the answer from one gentleman in the audience is that basically resilience for J offers a rate limiting feature. Other questions? Yes?
The dashboard that you showed for Hystrix is just for one web service.
Actually, I can show you how I did that. So here you have something that tells you it's a Hystrix dashboard, and you put like a URL to a stream. And because I'm using the actuator gives me a stream over Hystrix. So yes, if you want to have multiple services, then you can have like multiple dashboards for them. But again, I'm not sure it's really used for real. Yeah?
Another question related to the thing with the same service in different pods. As I understood correctly, Istio is related to one pod respectively. And what about if all pods are down? Is there a possibility to create on this with Istio?
So the question is, if other pods are done, can you do something with Istio? And the answer is, I don't know. I don't know. Yeah, it's not super great, but I prefer to tell you the truth instead of bullshitting you. I don't know. Other questions? Okay, thank you very much. Enjoy the rest of the conference.